Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about wireframes in 3D in GameMaker. So last week I made a video on line strips and line lists, and some of the things that you can do with them to jury-rig a wireframe visualization for 3D models in GameMaker, which basically boil down to replacing the primitive type from a triangle list or perhaps a triangle strip to a line strip or a line list when you draw your vertex buffer in GameMaker. And today I'm going to take perhaps another half step forward from that and talk about a somewhat better way to do that. And this is going to involve, instead of just replacing the primitive type in an existing triangle list vertex buffer with a line strip, instead we are going to actually recreate the vertex buffer so that it looks a little bit better when you draw it with a line list primitive type. So this is going to involve some vertex buffer manipulation. Where are the trees loaded in? That would be here, I believe. So a long time ago, back at the beginning of me starting to make 3D and GameMaker videos again, I talked about vertex buffer manipulation and how to, for example, iterate over each vertex in a vertex buffer and how to do things to those vertices. And I'm going to return to that. We're going to be doing some of that again today. Obviously, you can just load in a vertex buffer containing this information off the disk with the buffer load function, and that will be considerably faster than having to compute all this information on the fly. So I've got a vertex format in this project, and it's pretty basic. It's a 3D position, a 3D normal, a 2D texture coordinate, and a color. And this is typically probably the most common vertex format that people use in 3D and GameMaker. If you're being fancy, you might use something else, but if you're being fancy, you probably already know how vertex format works, and I don't have to tell you. I am going to go and create myself a script, a function, and I'm going to call this, let's say, vertex buffer to wireframe. And vertex buffer to wireframe is going to take a vertex buffer that was either created or it is going to be loaded from a file or something of that nature, and it's going to convert it to a wireframe. And the inputs that we're going to give it are going to be, let's say, VB trees wireframes is going to be an array, and I'm going to convert each of the vertex buffers in this VB trees array to a wireframe vertex buffer, and this is going to be vertex buffer to wireframe, and it's going to take as an argument VB underscore trees index 0, and then trees index 1, trees index 2. It probably would be considered like clean code to pass the vertex format to this function as well, instead of just like going in and grabbing that variable there, because software design principles make the world go round, but well, maybe not today. So in this vertex buffer to wireframe function, let's define u as taking an input parameter called vbuff, and we're going to iterate over this vertex buffer, and we're going to pull out the relevant vertex information, and we're going to transform it a little bit. So right now, the information in this vertex buffer is stored as a triangle list. So it is stored as a set of vertices. It is stored as sets of 3 vertices, 3 per triangle. So if you have a triangle with 3 points, A, B, and C, this vertex buffer simply stores in that order the points A, B, and C. And if we want to draw a wireframe using a, for example, line list, we're going to need to rethink how those vertices are ordered in the vertex buffer a little bit. So a line list is going to draw a line from point A to point B. All right, we understand that. But then instead of picking up at the next vertex as vertex C, we're going to need to draw a line from vertex B to vertex C. So we're going to have to double up vertex B. And then we're going to have to draw, to complete the triangle, another line from vertex C to vertex A. So instead of having 3 vertices per triangle, we're going to have 6. And that is a little bit inefficient. If GameMaker allowed us to use things like index vertex buffers, it would be a little bit simpler and we wouldn't have to duplicate so much data. If you wanted to draw a wireframe in a shader, you wouldn't have to do this at all. But those are subjects for another day. So let's get going. So the first thing we need to do is, this is a vertex buffer, and unfortunately GameMaker does not give us a way to just iterate over the data in a vertex buffer. It would be rather nice if it did, but alas, here we are. And I need to convert this instead to a regular buffer. And we can do that with a nice function var. I'm going to call the, like the regular buffer version of the input vertex buffer of our data is going to be buffer create from vertex buffer. And the vertex buffer is going to be vbuff. The type is going to be buffer fixed, because we don't need anything fancy, and the alignment is going to be 1. Important to note that if you have frozen your vertex buffer after, for example, after loading it from the model file, this will not work. GameMaker cannot convert a frozen vertex buffer to a regular buffer. It can only convert unfrozen vertex buffers to the regular buffer. So if you used anywhere the function vertex freeze, which is generally a good idea, generally will be a minor optimization that you can do. But freezing a vertex buffer does have some consequences, among them being that you cannot modify them and you cannot convert them to regular buffers. So we now need to iterate over each of the vertices in this buffer. Maybe I should say we need to iterate over each of the triangles in this buffer. We need to pull out the vertex information for each triangle. So you can iterate over this in any number of ways. You can use a for loop, you can use a while loop, you can use probably a do until loop if you really want to, but I'm not really a fan of do until. I'm going to use a while loop, so while buffer tell data is less than buffer get size data. We're going to iterate over this, and I'm just going to read from the beginning to the end, and I'm going to format the data that I pull out in the following way. So I'm going to say AX because we're dealing with point A, the first point in the triangle. And first we're going to read out the X position. AX is going to be buffer read data. The type is going to be buffer F32 because generally, unless they have reason to be otherwise, values inside vertex buffers are 32-bit floats. The only exception in my case is going to be the color. Var A, Y is going to be the same thing. Var AZ, same thing. And that's the position. The normals are also going to be 32-bit floats. Var ATX is going to be the horizontal vertex texture coordinate. Var ATY, so text Y is going to be the vertical texture coordinate, or U and V if you prefer calling them that. I don't really know why. I always call them TX and TY, but U and V is also common. And then it's going to get to the color. So you could say var A color is going to be buffer read, and then instead of reading out a 32-bit float, you could read out a 32-bit integer, an unsigned 32-bit integer, or you could read them out 1 byte at a time, which I think I'll do for legibility purposes. I'm not usually one to do this, but I have decided that for videos it does make it easier to read out red, green, blue, and alpha from a vertex buffer like this in that order, because I think it does make it easier to read than reading out an integer and then having to convert it to this, that, and the other thing. And obligatory shout out to the byte order of colors in GameMaker. Red is stored as the least significant bit, green is stored as the second least significant bit, blue is stored as the second most significant bit, and alpha is stored as the most significant bit in a when color is encoded in a vertex buffer. And you might expect these values to come out backwards, but because of the byte ordering that GameMaker uses, that being little endian, you can read them out red, green, blue in that order. Red, green, blue, and alpha. So that's going to be all the data for the first triangle. Next, we can do it for the second triangle. And thirdly, we can do it for the third triangle. So this is going to be a bit of copying and pasting. We're going to read out these, what is 36 times 3? 108 bytes for each triangle. And we now have them arranged in this A, B, C, in these groupings over here. And we can do whatever we want with them. And what we want to do with them now is going to be to write them into another vertex buffer. So we're going to want to write them into, let's call it var wire buff. And we can say this is going to be vertex create buffer And we can say vertex begin wire buff, and the vertex format is going to be camera.vertex format. Again, you may consider it a good idea to pass that in as a parameter to this function, but I'm just going to hard code it. And we are going to next write in some of this data into the wireframe buffer. And we can do that with the vertex position 3D function, and that's going to be wire buff. The x is going to be ax, ay, az, vertex normal, wire buffer, a nx, a ny, a nz. I did call them that, right? They're not showing up. They should be. All right. The syntax coloring is just taking a minute to catch up, I see. Thirdly, vertex text chord, wire buff atx, aty, so the horizontal and vertical texture coordinates. And lastly, vertex color, wire buff. And color is going to be make color RGB. Red is going to be AR, AG, AB. And the alpha is going to be AA. And you can either do this 2 more times, written out each the long way, or... And it boggles my mind how many people get confused by this. Guys, vertex add point is a function that I wrote in GameMaker when we were doing vertex buffers way back in the beginning, so that you don't have to type this out manually every single time, okay? I don't know why so many people seem to have trouble with what exactly vertex add point is, and why it's not part of GameMaker by default, like why it's not built into GameMaker. Guys, this is to make your life easier. So, what the vertex add point function is going to allow us to do is vertex add point, and it's basically going to allow us to do this all in one line. Wire buff ax, ay, az, nx, ny, nz. Sorry, that should be anx, any, anz, atx, aty, and then the color. And lastly, the alpha. And that's going to be a lot nicer than having to write out those 12 lines of code manually. So now we can just... where's the B key on the keyboard? I know how keyboards work. Update all these values. And we can get rid of this this last block of vertex add point. Like, not to mock my viewers about this or anything, but if I had to pick something that I thought a lot of people get hung up on when it came to making 3D games in GameMaker, I would have thought that it might have been like m.l or, I don't know, some other lighting calculations or, I don't know, how shadow maps work or something like that. I would not have expected it to be this function. It's been very strange. I've been talking and also sort of complaining without actually paying attention to what I'm doing. So these are 3 points. These are the 3 points of the triangle, and right now we're just kind of writing them into wire buff as is. What we're going to want is, I said that we're going to want points A and points B, and those are going to be connected by a line, and then we're going to want points B and points C, and those are going to be connected by a line, so we're going to have to, if we were grouping these together, you see A and B, B and C, and then for the third line, the third edge of a triangle, we're going to want point C again and point A, and that is going to complete our, triangle if we were to draw them connected with a line list. And when we're done with that, we can say vertex end, wire, buff. You can freeze it if you want, as I said. Not strictly necessary, but you can do it, and it will give you a small performance boost because GameMaker won't have to consume as much GPU bandwidth when it draws a vertex buffer, but in exchange you won't be able to mess with it later. And we should also buffer delete the regular buffer that we created containing the raw vertex data of the source. And lastly, return wire buff. Now let's actually draw these. So if I were to go back to the create event of the camera, the tree position struct. Right now, this set of tree position data comes with an X, a Y, and a vertex buffer, which is just going to be one of, like, a random tree. A random VB underscore tree, which is the vertex buffer that is intended to be drawn as a triangle list. And if I were to instead also give you, let's say wbuff, so that I don't have to type out wire buff every single time. VB trees wireframes index. So we're doing the same thing here, but we are saving the randomly generated index in this array, and we are assigning the vertex buffer, and we are also assigning the wireframe vertex buffer, so that each tree knows what its like its regular vertex buffer is, but also its wireframe vertex buffer like this. And in the draw all the stuff script, we could say, let's say if you hold down the spacebar, we'll draw the wireframe version of the vertex buffer. If you're not holding down the spacebar, we'll draw the regular one. That's going to be PR_triangle list. And if we're holding a spacebar, I guess I'll comment this. We can draw, instead of tree positions index I.vbuff, we can draw tree positions index I.wbuff. And we can draw this with a line strip primitive type. And now when I run the game, and when I hit the spacebar, and I'm going to apparently have misspelled a variable somewhere. Oh, WB. V, W. They look the same. W is really like a double V visually. Anyway, I see they randomly spawned in different locations this time. If I hit the spacebar, and if those looked funny to you, I had one job. We want to draw the wireframe buffers with a line list instead of a line strip. I've been saying line list the entire time, and I still typed in line strip anyway. So if we hit the spacebar, we now have a perfect wireframe representation of each of these trees. And we don't have any random lines hanging off. We don't have any random lines connecting vertices that shouldn't be connected. We don't have any edges of any of the triangles missing the way that we did before. And that is due to the fact that the vertex buffers are now formatted to draw with the line list primitive type instead of triangle lists. And that is because, as stated, the vertex buffers that we're drawing with the line list primitive type are now have now been built with that consideration in mind. And they look a little better than the hacky solution that I had at the beginning of the video. Okay, I thought there was one missing, but as it turns out, this line here just happens to be almost exactly the same shade of green as the ground. And it's like the lines, the pixels comprising the lines are still shaded. They still have the lighting calculations being run on them. And you can see that the like the tree trunks that are on like the back of the trees are darker than the tree trunks on the like the light facing sides. And if you didn't want that, you could either just you could either draw them with a different shader that doesn't do the lighting calculations on the wireframes, or you could at least give them a vertex color of white so that they're not like green and brown or whatever. But I think this looks cool. As I said, I have a bit of a liking for wireframe models, for a good wireframe model. And I do think these look it's an aesthetic, you know? So I'm going to end this off here, I think. As I said at the beginning of the video, and also in the last video, there are other ways to draw wireframes. This looks pretty good, but it does come with the downside that you need to pre-process all of your vertex buffers into a format that can be like drawn nicely with a line list. And it does take some extra computation time to convert the regular vertex buffers to a wireframe vertex buffer like this. And it also requires basically duplicating all the models in memory, which is not the most ideal use of memory. And there is a way to draw wireframes in 3D using a shader that does none of this. But that's going to do it for me for today. If you want the code for this, look for the GitHub repository down in the video description. Apparently, I have not committed any of this to GitHub. I should probably do that. I have a Patreon, so if you want to contribute to the channel, look for the links to that in all the usual places. Otherwise, I try to post about 2 game dev videos a week, one tutorial like this, and one Let's Make a Game, currently Bullet Hell. Until next time, I hope you all found this interesting, and I will see you all later. Special thanks to Army Armbuster, DJ Gibbles, Edward Holt, GameMaker, Harold Guidry, Kiexi, Sindra Larson, Squarecrow, The Oz, and Zenzerman for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.